So this is a graduated cylinder. It's obviously a cylinder, and it's called a graduated cylinder because it has these measurements or markings on it. When you're using a graduated cylinder, especially if you're using a glass cylinder or a really narrow cylinder, water will make a slight curved surface. It's called a meniscus. And you always read the bottom of the meniscus. This one is kind of wide, and it's also plastic, so we're not going to get a very strong meniscus. And then sometimes when you're trying to read one, you might need to put a piece of paper behind it to make it a little easier to see. And you always want to read it at eye level, okay? Because if you're reading it like this or like this, you may get a slightly faulty reading. All right. So if we look at this one, it's 300 right here, 350 here. So from this mark to this mark is 50 milliliters. There's a halfway mark right here, and so that must be 325. And that means each of these little marks is 5. So this would be 305, 310, 315, 320, 325. 330, 30, nope, 25, 30, 35, and then 40. So I have right at 340 milliliters of blue liquid in this graduated cylinder. And that's how you read one. I have a glass graduated cylinder and the plastic one from before. Notice this one is much more narrow. It's shorter. This one only goes up to 25 milliliters. And of course it's more breakable because it's glass. We're going to put a piece of construction paper behind it to make the numbers easier to see. We're using dark paper because the graduations on the cylinder are white. Now if we come down here, this is 15 and that's 20. So there are 5 increments between the 15 and the 20. And we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there are 10 increments, and from 15 to 20, that we know that's 5 milliliters. We divide that by 10. Each one is half a milliliter. So then, if we get a little closer here, and remember you're always going to look at eye level. Now if I turn this a little bit, maybe, you can see, I don't know, how the surface curves a little bit. If we look back at the large one, the water just looks flat, right? But if we look here, okay, there's a little bit of a curve that the water is following. See, it's kind of starting up here and curving down a little bit. If this was more narrow, you would see it curve any more. That's because of the cohesion, or adhesion. The water molecules want to stick to the glass, but they also want to stick to each other, so it causes it to curve. We call that a meniscus. You always read the bottom of the meniscus, not the sides, but the bottom. So we're going to turn this back around, and we look at it at eye level. So it should be right in front of the camera if we're looking at eye level. And again, this is 20. So that would be 20.5, 21. This mark would be 21.5, but it's not quite there for reading the bottom. And it looks to me like the bottom is just touching the 21. So I would call this 21 milliliters. I might call it 21.25, because if that's 0.5, then halfway between would be 0.25. But I feel fairly precise in saying that that is 21 milliliters. One other thing I want to show you real quick while I have your attention. This is a pipette. Okay, so it kind of looks like an eyedropper. You squeeze the bottom and it lines up. Now, but the cool thing about this one is, and you may or may not be able to see this, it's a 1 milliliter pipette. So that mark right there means 1 milliliter. If you look, there's 1, 2, 3, 4 markings. So that means this would be half a milliliter. That would be a quarter of a milliliter. So you would, whoops, sorry, almost dropped my phone. All right, you would insert that into the liquid. Well, actually, you would squeeze the top, insert it, and then draw up the liquid, push down to 1 milliliter, and then you could transfer that milliliter to another container. All right, so this is for when you need small amounts of something. Sometimes you might just use it without really measuring. Sometimes you need to actually measure with it. So that's a pipette.